We want to look at the equation of an ellipse where its center is at the origin of the coordinate plane. And to motivate the idea here, I just want to remind you that if you wanted the equation of a circle, if its center is at the origin, notice the distance here in a circle is the same as the distance here. In an ellipse, those two distances are not the same because you have a major and a minor axis. Okay, so this distance is called the radius in a circle, and the equation of this circle is x squared plus y squared equals r squared. Now if you divide everything here by r squared, you get an equation very similar to the equation of an ellipse. You get x squared over r squared plus y squared over r squared equals 1. So notice the right hand side is 1, you've got a plus between these two things, and you're dividing by r squared on both of them. And that's because horizontally and vertically this distance is r. Well, that's different up here. What we're going to do is, in this ellipse, the distance from the center to this, what we called minor vertex, we'll call this distance lowercase v, and the distance from the center to the vertex we will call capital V. Okay? So since you don't have the same distances here in a circle, you're not going to have the same things on the bottom for the equation of an ellipse. So what we end up with is something like this for the equation of this vertical ellipse, because its major axis is vertical. Vertical ellipse. Alright, let's just label it vertical for the interest of time. The equation of this is going to be x squared over some number squared plus y squared over some number squared equals 1. Now what number goes underneath? Well, notice that the lowercase v is on the x-axis. So you're going to have lowercase v squared here. And capital V is on the y-axis. It's vertical, so you're going to have capital V squared here. And you could probably guess over here that this distance is lowercase v, this distance is big V, right? I'm trying to emphasize big V and little v. So the equation of this horizontal ellipse is similar. It's x squared over big V squared, because big V is horizontal and x is horizontal, plus y squared over little v squared, because v is vertical, equals 1. And that's the equation of an ellipse. Now I just want to remind you where the foci are in each of these pictures. The foci are on the major axis, so my foci are here and here, or here and here. If I wanted to figure out exactly how far from the center that is, meaning this distance, let's call it f for focus, then it's true that they satisfy the Pythagorean theorem, where big V is like the hypotenuse. So little f squared plus little v squared equals big V squared in both pictures, and you could solve this for f to figure out this distance. Let's look at a simple example. Here's an ellipse. Let's try to find the equation of it. Well, I know it's going to be x squared over something squared plus y squared over something squared equals 1. Now, x squared is going to be over 3 squared, because this horizontal distance from the center is 3. Y squared is going to be over this distance squared, because that's the distance from the center, so that's 4 squared. So we have x squared over 9 plus y squared over 16 equals 1. Now, if you want to know where the focus is, it's somewhere in this area. We don't know exactly where it is, but we do know that f squared is smaller than the 4. This side is the other small side, so 3 squared equals big V squared, which is 4 squared. So f squared is 16 minus 9, so f is the square root of 7, so here's the focus.